Perfect. Yeah, welcome to the series lecture Agroforestry. It's the second lecture and it's a bit special as Stefan Leu is not here, but in Israel, and he will have his lecture in English. Yeah, I'm very glad to have him today with us, as I also don't know what he's doing and I'm really excited about. Yeah, as I am coordinating this module and the agroforestry community is also helping, I want to thank the agroforestry community and Marius too, and also for the financial support, the Stier-Stiftung and Studienqualitätsmittel. I'm interested, where are you from? So what are you studying? So are you studying forestry? So please give a sign. Okay, about 8, 10. Okay, and agriculture? Similar. Ecosystem management? Oh, wow. Other studies? You're not studying? Okay. Yeah, very, very interesting. And you not speaking German very well, so you're very happy about an English lecture, please? Okay. Yeah, thanks so much. I will hand over to Marius, who gonna tell you a bit about Stefan, and then we will have the lecture. Thank you.
Yeah, thank you, Franziska. First of all, I want to say that this lecture is recorded. So we have their camera, we have a camera over there, and we make a screen recording. So if you if you want to say something and you don't want it in the recording after that, just give me a sign and then I will cut it out. And I will also want to say hello to Gießen, Kleve, Lüneburg, Eberswalde, and Kiel. There are Noel, Colin, Svenja, Niklas, Marco, and Julia who are supporting us, and they are having their own space in their city. So there we have a cooperation with other universities and other organizations. I also want to say thank you to the Agroforestry.Community Orga team in Göttingen. And also want to mention that, we have the support of the university here in Göttingen. And this is also, worth to mention that. And yesterday I was thinking about, okay, what do I say when I'm here? And I was thinking about, it was in a museum and there was a cupboard. And in Germany, this is called Schrank. And when we have a Schrank, then we put stuff in there, and we have drawers and Schubladen. We put stuff in Schubladen and put it out and put it in. And in German, you also have the word Schranke. So you have the barrier, and with barriers, you can divide stuff. And we have some artificial barriers in our head, what we can dissolve. And we can start thinking about stuff holistically and more. And recreate a new future where we look at topics interconnected and separate some topics. For example, food, forestry, climate change, biodiversity, soil, social and economic aspects. And today we start looking to on vegetation and ecosystem health and climate change. And therefore we have as Franziska also already mentioned, Stefan Leu here. He is a scientist in Israel, and he's studying or researching in the field of ecosystem restoration and restoration landscapes. And please give him a warm welcome. And I will go give my word now to Stefan, who can share his screen. And thank you that you are being here. And after 30 minutes, we will make a short break and have 10 minutes to discuss. And after that, again, 30 minutes of 30 minutes again of presentation, then 10 minutes break, and then 30 minutes again, and 10 minutes break. So I think you got it. And yeah, thank you, Stefan. And yeah, welcome in Göttingen and other cities in Germany.
Good evening. Thank you very Marius. Thank you very much for the invitation and for the opportunity. And I will start right away. It's an extremely ambitious evening program from my side, and I hope I can mediate the content as well as possible to everybody here, and hope for a fruitful discussion afterwards. So the topic of the talk is actually ecosystem restoration and global warming, and it is divided into 3 chapters. The first one is a connection between vegetation, hydrology, and global warming. And this is the key question, actually, because originally, especially in drylands, it was disputed that the restoration, especially by forestry, would help, because it was assumed that trees would evaporate all the water. And in the course of our research and other research in Israel, forestry research turned out that the contrary is true. Actually, forestry in degraded drylands will improve significantly the water balance of the location, and has also global implications. So the content is of chapter 1 is vegetation and climate, and I will talk about global scale ecosystem conservation and restoration to stop global warming, restore land degradation, water circulation, and conserve enhanced biodiversity. And then I will talk especially about the dryland work we did in Israel, and that's on that subject. And the third is the most ambitious ones, namely how can we move ahead and realize a groundbreaking initiative to move ahead, restore degraded ecosystems, and by this reduce or stop global warming. So first few sentences: global warming is an imminent existential threat to the Earth's future. And actually not to Earth's future, to mankind's future. And point 2, all the scientific and technical tools to rapidly stopping global warming are available. And 3, there is an extreme resistance from the global capital tycoons, global industrial complex, and others to prevent progress. And we are not actually talking about a scientific challenge. We are talking about a full-scale global revolt against I call it the capital, against the rulers of the world. Global warming, I don't know how often you read the newspapers. If you more or less daily read newspapers and internet sites, you should know that we are in a stage of a runaway global warming situation. The temperatures and temperature-related phenomena are increasing on a daily basis. We are at almost 1.5 degrees global warming for the last couple of months. We have also been at unprecedented ocean temperatures that are about 1 degree above what was observed previously. The result is logical. I mean, Antarctic sea ice is a record low extent by a significant margin compared to the last following year. And this is starts inducing very serious feedbacks that will affect the climate, and it will affect the climate in the warming direction. And those are the Amazon rainforest, both because of deforestation and because of global warming, losing its function as a global climate regulator. The Arctic sea ice is withdrawing and starts to release the glacier water from the Arctic, from the Antarctic. The Antarctic Atlantic circulation is being affected, is being reduced. Boreal forests are becoming far more fire sensitive. Coral reefs are being destabilized, as is the ice sheet of the Greenland, which by itself can raise sea levels by many meters. The permafrost is thawing, releasing greenhouse gases by itself. So that's a massive amplification of warming trends we can see. And in Antarctica, we have two critical observations that will lead to rapid sea level rise. And this is a hypothetical scenario that has been published, that if we reach 2 degrees warming, the Earth will enter into a new, because of those feedbacks, into a new stage of hothouse Earth that will jump us to 0 degrees warming and many meters of sea level rise automatically, without and this and many other things have not been considered, nor have they been discussed by IPCC. And there we are in a real problem, because those high-risk scenarios have not properly been assessed by the thousands and thousands of scientists that have been involved in IPCC reports. And the bigger problem, the world does not want to wake up to the challenge. Coal, there are 20 huge coal mines planned to be opened in the next 3 years, and they themselves will emit so much carbon that we will necessarily go beyond the 2 degrees centigrade warming. They write here that it will be more difficult to reach the 1.5 degrees limit, but we are already at 1.5 degrees, plus minus 0.15, 0.2 maybe. And we will, with certainly in the next 5 years, cross that border that has been considered critical. And we are already now at levels where we have irreversible processes going on in terms of melting of Antarctic glaciers. Their melting cannot be stopped anymore because the warm ocean water and the warm air temperatures are melting away at glaciers that with mechanisms that cannot be stopped by simply reducing now greenhouse gas emissions. And these glaciers that are melting by themselves can raise sea level by over 5 meters. Now, if we are living close to Hamburg or in Holland or anywhere there, maybe you better sell your property before it's too late. Now, what has this to do with agroforestry? That's a subject I went in about 40 years ago. There were big discussions about ecosystem degradation, deforestation, lots of biodiversity. And indeed, if we look at this graph, we see that most ecosystems, major ecosystems like Mediterranean forests, tropical forests, and so on, have been destroyed already now by more than 50%. And we expect a further loss until 2050. That is from the International Union for the Conservation of Nature. Not a very new graph, but that's the situation. And it's ongoing. And this destruction adds about 8 billion hectares of degraded lands, and CO2 emissions from this destruction is in the 1,000 gigaton range. That's 20 years of current emissions. It probably is more. And only restoration of this degraded land can save us at the current moment. This is a scheme that has been designed based on the Paris Agreement. The idea was that by 2020, the emissions should start going down. If we want to reach 1.5 degrees, it should have gone down rapidly at a very steep rate. To get to 2 degrees warming, it should bend down much slower. And the calculations were then that to reach the 1.5 degrees warming, we should have saved then by 2020 already 19 gigatons of green CO2 emissions per year. Nothing of that has happened. We are still we are here now, business as usual. And if we want to achieve something, we have to do start to do carbon sequestration. That means green CO2 negative processes. For example, by restoring 3 billion hectares of degraded drylands, and 2 billion hectares of degraded farmland, and 2 billion hectares of degraded forests, to get about 25 billion tons per year of sequestration. That is possible. Everything else is not possible. And to limiting emissions from fossil fuels within immediately is not possible. Now, restoring such ecosystems and forests will also modulate the climate in a positive way in many other ways. Forests are making the climate. If we remove forests, we get desert. You see here an ecosystem near San Francisco, near the sequoia forest, which is a moist forest. And where the forest has been removed, we have a semi-arid steppe down here. And it's dramatic to be there and to go walk through this steppe and then enter the moist, huge forest with huge trees. But this forest cannot return. Once it has been cleared, it cannot return by itself. It is lost forever, unless we go and plant it again. The same thing with the desert cloud forest in Oman, same thing. The reason is that those forests live in fog-rich areas along the coast. They capture fog, and the fog drips down as precipitation and adds at least the same amount of precipitation as they get from rain. Now, this perennial vegetation affects microclimate and hydrogen in many other ways, and we show that also in the next chapter. This is an experiment we made inside acacia woodland in an area with 200 millimeters of mean annual precipitation, which were very little, but those acacias absolutely love it there. And we thought, okay, let's see what is an olive seedling doing in this area where the soil is much improved by the trees. The climate, microclimate is much improved by the shade, windbreak, nutrients, everything provided by the acacia. So one hypothesis is that the acacia will outcompete that tree, take all its water and kill it. But the contrary is true. That olive seedling grew very, very well. We planted in spring, gave it 1 bucket of water. It grew extremely well, survived through summer, grew into the next year. So that's a very interesting observation. If we restore appropriate forests or woodlands, we get much better water exploitation. We get much better biological productivity, and that's seen here as well. We measured here productivity. This is measured. That's the NDVI. So we measure biomass, green biomass, from space, and we see in the conserved area with good soil and with the acacia trees inside, we have at least double the amount of vegetation produced than in a degraded location where eucalyptus trees have been planted by a very unfortunate methodology. So we get more than double of the vegetation. When we measure it, is actually much more. And the reason, again, in this woodland that I showed you, we achieve very early in winter very high water content of the soil of about 25%. Those areas outside of this woodland have between 40 and 50% of the moisture, and for a much shorter time. And therefore, this is in complete contradiction, actually, to many agroecologists' dogmas that were running around then, 20 years ago, 30 years ago, and today, even today, still with many people. And so this is a methodology that can be exploited to restore huge amounts of degraded drylands that exist in the world, maybe 10 million, 20 million square kilometers, by dense planting of agroforestry woodlands or forests, whatever is suitable, also native forests, native vegetation. The problem is it has to be planted. It doesn't come back by itself. It has to be planted. And now, let's go ahead. This green vegetation has another effect. Green vegetation reflects radiation into space at those wavelengths. And you see here, the major greenhouse gases actually don't absorb energy in those wavelengths. These are the absorption bands of CO2 and of water and of methane. And you see, their major absorption is up here, where only soil, bare soil, reflects heat. This is long wave heat radiation going up into the atmosphere, is being trapped by those greenhouse gases. When the radiation comes from plants, the radiation is not being trapped, it's going out into space. Now, deforestation alone still adds about 8 gigatons of greenhouse gases per year to the atmosphere. This is a palm oil plantation. I mean, it's a scandal what is going on in Indonesia. They claim they stopped it by now and they have reduced it by 70%, but it is probably too late. They have emitted so much CO2 that the world has suffered extremely, and the ecosystem, the orangutans, all the animals that live there have dramatically suffered by this. Brazil, the same sad story. This is the area of Mato Grosso and Rondônia 40 years ago. This yellow shape is copied from down here to up here. Everything green in this shape, here is all gone. The same thing on down here on this side, all the vegetation gone. And that adds up to about 500,000 square kilometers of forest that have been cleared in 40 years. That's the size of France. And it has an incredible impact on the hydrology of the Amazon basin. They said that this publication says that the Amazon needs 80% of the trees remaining to continue the hydrological cycle. But where we have seen in this cleared area, it's over 50% loss and has an impact on flood control and droughts. And we see here a huge drought right now. Brazil claims that global warming is responsible. I claim deforestation is responsible for this. And it can be checked, obviously. But that doesn't really matter. The problem is, how can we fix it? In Africa, the same thing, deforestation massive. That's a place in Kenya that I especially like. In 1970, there was a wonderful forest here along the so-called Mau escarpment that completely disappeared and led to silting up of Lake Nakuru. If you know Lake Nakuru, the lake of the flamingos. And well, they started to correct it a little bit, but in general, in Africa, deforestation is the result of poverty, but also creates poverty. It creates erosion, it creates poverty, it creates hunger, it creates war, and must be stopped. There's no other way around, because Africa is the only continent where there is still significant population growth going on. We have to restore the ecosystems in Africa. And the forests don't come back by themselves. That's what they said. We have to reforest massively to stop erosion, stop desertification, supply fuel and industrial wood, and stop disastrous floods and droughts, to restore climate stability and regulate precipitation. And all this could actually be paid by carbon trading. If people that want their CO2 to be absorbed are willing to pay, the money can be taken to reforest. Now the question, does it work? Of course it works. This blue graph is a little place called Switzerland. In the middle of the 19th century, suffered heavy flooding on almost a yearly basis because the mountains had been deforested to provide wood for the industrial towns around. In all the watersheds of the major rivers, here, those red lines are the dates when forestry laws were enacted, and 10, 20 years after that, after reforestation had been started, the floods stopped. And so it works. And you can design watershed protection measures for flood control measures for any area that suffers of floods, like India, Pakistan, North and East Africa, Australia, and so on. You can do it. Now, in drylands, I bring a citation from an expert from 2,500 years ago. That's Plato, and he wrote, I will read it because this is very, very crucial sentences. Soil has been carried to the bottom of the sea. Earthy high mountains that in the past carried tall forests and large pastures have become rocky lands and look like the bones of a sick body over here. And in the past, rainwater was utilized and did not run on the barren land to the sea as it does now. It infiltrated and stored into the soil, and it was distributed in springs, fountains, and river streams. That's happening when you have a forest. So I go on from that. There is the saying, trees evaporate water, trees never evaporate water. Trees have small openings called stomata that they can open and close in order to let in CO2, which they need. And when they do that, some water is running out, and they also release excess oxygen. And so they don't make photosynthesis when it's hot and dry. They make a photosynthesis early in the morning in fall, in winter, when it's moist, when they have water, they don't make photosynthesis when it's dry, so they don't evaporate water. They have another effect. The leaves heat the air and moisturize it a little bit, so that warm, moist air starts rising, condenses in higher altitudes, like here, forms clouds and rain. And that's what we see. If forest is removed in tropical areas, we see formation of clouds. And I think that's the last genius thing trees know to do. They store their own water deep down in the soil. And they use water movement through their tap roots and their lateral roots, moving it around to manage water supply to their crown to make photosynthesis, or to save water when it's dry, in order to not overexploit the reserves of water they have in the deep soil. And so, in short, I mean, trees and vegetation in general, they have adapted to possible water shortnesses and variations in water availability. For a long, long time, they survived 500 million years and learned for 500 million years. And well, we call that intelligent water management. We'll call that intelligent water management in order to maximize their chance of survival, which is the purpose of evolution. And it is extremely important to keep that in mind, that with the help of trees, we can achieve huge benefits for environments, not only moist environments, but also dry environments. Okay, and thank you. I think that's this for the first chapter. And I will look forward to some questions and discussions. Thank you. Hello, anybody there?
Hello, Stefan.
Only 2-3 persons left. Everybody ran away?
No, they're still there. We have two questions in the chat. And the first question is why the forest doesn't come back by itself.
Why the trees, vegetation don't come back, especially in dry areas. What happens if you remove the trees and remove vegetation? We will see it in the next chapter. Actually, we have perfect illustrations for that there. You get a smooth surface where wind removes all the resources, wind removes all the dust and all the seeds, and the water washes away all the resources on the topsoil, and the seeds have a very, very hard time to catch a location. And secondly, the soil moisture goes lost very rapidly. The soil gets compacted. Water cannot penetrate, does not infiltrate anymore into the soil. We have all those data measured. And so even if a seed manages to catch, and even if it manages to catch roots, it has water only 10 centimeters deep. And this water in summer, this moisture will dry out completely. So the seedling has no chance of surviving throughout the summer. And that's why what we actually need is a soil structure where we have on top some organic layer. We call it mulching. Okay, we spread mulch on top of this kind of soil, and then we don't need need other trees. but we need this kind of mulch. It can also be from annual vegetation. If grass grows well and starts building layers of organic matter on top of the soil, it becomes suitable to catch seeds, also of trees, and then slowly we get the forest back. So it's an interaction between excessive grazing, very low production of biomass, and the removal of this little amount of biomass by grazing, which creates actually a desert. Okay, that's the process of desertification.
Thank you. Well, there's another question in chat. How does deforestation relate to the destruction, adding 1,000 gigatons of CO2 equivalents?
Well, that's deforestation and ecosystem destruction over the last hundreds of years. Okay, this is, you saw that graph of the International Union of the Conservation of Nature, how much of each ecosystem has been destroyed during the last 100 or 150 years. And this is a huge amount, mostly Mediterranean forest, tropical rainforest, temperate forest in Europe. Europe was all forest 3,000 years ago. A lot of America, North America, much of Africa and Asia have been forested 1,000, 2,000, 3,000, 4,000 years ago. I will have a scheme later in a later graph. And all of this biomass has been harvested and burnt. Okay? And that calculations are that it's about 1,000 gigatons of CO2. There are calculations that even double or triple that amount. And furthermore, destruction of soil. Soil contains organic matter. And by making agriculture we make in the Mediterranean room, we make agriculture for 10,000 years now. And in other areas, like in the United States, in the prairies, in Asia, in China, in India, we make agriculture for hundreds or thousands of years. And the soil organic matter is being oxidized and transferred into the atmosphere. So it is a huge amount of carbon dioxide that has been transferred into the atmosphere by destruction of ecosystems.
Thank you.
You're welcome.
We would now read one more question from the chat and then continue with your presentation and do the next questions like in the next pause.
Okay.
So the next question, or is there a question in the room? Okay. Is which family names of plants are now necessary to start with?
Okay.
How to start?
I specifically did not go into species and don't go into species because I did not want to overload here the presentation. Very important species for drylands is acacia. Now, for European ecosystems, I will talk a little bit about Spain. It's Pistacea, and it is oak, which is Quercus, and pine, Pinus. Pinus is very widely used. It is suitable in Israel until 250 millimeters of rain. It is suitable in Spain. It is suitable in the north, and it's working actually everywhere. And so these are many of the major species that are being used, and there are many, many more. We brought species from Northern Africa that are suitable in Israel. I don't know whether they would succeed in Europe. Probably in southern Spain they would succeed. There is another group. It's actually not the species, the genus, that is Sisyphus. It makes edible fruit, grows anywhere, down to 50 millimeters of precipitation in gullies where the water runs off. They're fantastic there. They stabilize those gullies. They capture the water. They make fruit. In the Arava Valley, if you know it, that's the driest place of Israel. Receives about 50 millimeters of rain. And you will find the Sisyphus down there in the most unexpected places. So that's about what I can throw out right now. You can remember eucalyptus. Eucalyptus has been widely used, unfortunately, during the period when it was able to collect money from planting trees. And eucalyptus, because it's growing very fast, was planted so that you could claim carbon dioxide credits as fast as possible. The problem is that that eucalyptus is making a lot of ecological problems. It depletes the soil, it depletes groundwater, it destroys natural herbaceous vegetation, and it's not edible for anyone. So it's not a plant of choice to be planted.
Thank you.
You're welcome.
So now if you like, we can continue with your presentation to stay in time.
Okay.
Thank you.
Okay, I open the next presentation. Okay, now that's actually the subject I started to work on about 30 years ago, actually even 36 years ago by myself, and about 30 years ago in terms of working. And desertification was considered one of the major problems then. And well, it was hoped that it would be solved by now, but it's getting worse because people don't really pay attention to nature. And this is a scheme from, I think, 1998. It shows where desertification is going on. Desertification, well, is what I said, is removal of vegetation by overgrazing or by cutting trees or by any other mechanism. Loss of soil function, loss of soil fertility, and you get infertile, sealed soil that is not able to absorb water, that is not able to support plant growth in significant amounts. And you can guess the red areas are the most critical ones. We have them everywhere. We have a lot of them in Central Asia. We have a lot of them in Australia, which is surprising because Australia is actually a modern country that should be able to control it. And we have a lot of them in Canada and the United States. Again, the reasons being overgrazing and unsuitable agricultural exploitation. Orange is places where, well, it's pretty easy to fix it. And we have it in Europe, in Turkey, in Spain, Northern Africa, but also in America and Southern Africa, in Brazil, interesting, and Western Australia. And yellow is in danger of being desertified. Now, how much of those areas do we have? Because everything that is desertified, in danger of being desertified, requires treatment. And we have semi-arid areas, about 2.4 billion hectares. That's 24 million square kilometers. That's huge. And we have dry subhumid. Those are areas that have irregular rainy seasons. They have reasonable amount of rain, but the rain is irregular, and that causes problem. We have about 13 million square kilometers of that. Now the productivity expected in subunit is 4 to 8 tons of carbon fixation. That's times that's 6 to 12 million tons of biomass produced per hectare and per year. In terms of CO2 fixation, it's times 2.5. That's 10 to 20 tons of carbon dioxide fixation per hectare and year. And here in the semi-arid is about half of that. If we add that together, what potentials do we get? We get 15 tons of carbon fixed in these areas potentially. And those up here in the arid areas, I neglect them at the moment, even though they can be important as well. If we assume that 1/3 of the land is degraded, which is not true, it's actually all of it is degraded, but let's assume it's only 1/3 of the land is really degraded and needs treatment. That's 6 gigatons carbon per year, or 15 gigatons of CO2 per year. That's a potential we cannot neglect. And now the best approach is to go at it is to make agroforestry, to make actually high efficiency agroforestry, to make those lands fertile again and productive for people. We have been looking at two kinds of agroforestry. Agroforestry with dryland fruit trees, that's one. The other is silvopasture, where we plant trees that improve the rangeland conditions, that increase the growth of herbaceous vegetation that can be used for grazing, for range improvement for animals. Okay, the principle is very simple. We have trees, we have shrubs, and we have annual vegetation. Each of them shares a different slice of the soil, of soil depth. Each of them has a different height of canopy, so they don't really disturb each other. If it's the proper mixture, they support each other in a synergistic way, and we get actually more productivity if we mix them together like this than if we have only one species alone. Monoculture is always bad. Mixed cultures is better and better. Okay. Now, the first project we bought a farm in Israel when we got there 33 years ago. Okay, that's the way it looked. 1991. Okay, and everything looked like this then. That is the normal, considered normal. And it was considered that this is not desertified. No, that's normal. Until we started planting things. So we planted Mediterranean climate species, olives, pines, oaks, pistacea, and turns out that even here at 200 millimeters precipitation per year, they managed to grow well in dense groups of plantations, okay, where the trees support each other with the microclimate they create, and improve the soil, and therefore capture more rainwater into the soil and have less loss of water back into the atmosphere. Here we have many African and Indian species planted that perform extremely well in dense plantations, and you see that they do not inhibit the growth of grass, they support the growth of grass. And the third one is the biggest surprise, that this tree, Balanitis, it's an African savanna tree that also arrives in eastern, grows up to eastern Israel in valleys, but it's not found in the plains because it was never planted and it has very soft wood. That's why it probably was destroyed very rapidly. And it makes seeds that are useful to make oil. If you want to make biofuel, I mean, that's a tree to grow. You cover a large area of semi-arid, degraded farmland. You get those trees growing. The seeds are also eaten by camels and goats, but you can harvest the oil to make a fuel. There are many other trees like this that make fuel, oil in semi-arid areas, so it could be useful. Okay, and it showed that it's very, very easy. I did not apply any professional knowledge here or any kind of special nutrients or stuff like this. It's just planting trees, watering them for half a year or a year with drip irrigation, and then they have caught their roots, have caught depth, and they continue growing without any problem. And we get the wonderful savanna. You see how much annual vegetation and grass is growing. And we can say that we sequester at least 5 tons of carbon dioxide per year, per hectare. We have more biodiversity, more productivity. And as a conclusion, this arid and semi-arid ecosystems that very often appears just as a naked plain should be actually fertile savannas, woodlands, depending on the topography. And many tree species can massively improve soil fertility, hydrology, and productivity. Avoid eucalyptus and prosopis. They, first of all, don't belong here. They're not native. This is Australian, this is American, and they deplete water resources and suppress annual vegetation. Now, restoration of soil is the most critical parameter in all this. This is a piece of land that has been standing undisturbed without grazing for 15 years. And you see what happens to the grass? It decomposes and starts forming a litter layer on top of the soil, on top of the soil, the basic soil down here. This has been happening in the prairies in the North America for thousands of years. Therefore, they were so fertile, even though they have mixed precipitation levels. Trees, in this case, help by stopping winds. If winds remove that vegetation, then it can stay. This later cannot stay. It will fly away. If you have trees that break down the wind to normal speeds, you get a wonderful build-up of humus, as we call it, and that's that at the same time acts as a slow release fertilizer. The moment there is rain, it dissolves nutrients from this decomposing biomass down into soil, and you get fantastic fertility. And this is the book. This is like in the book. Okay, there is an O horizon. Now, experts in the University of Beersheba told me, well, you see, this is absolutely lousy soil here. We have not even an O layer. We don't have an O layer, and we hardly have an A layer. The A layer is also a layer with high organic matter. Of course, you don't have. If the soil is destroyed, you don't have that. If you let it reform, it reforms, and you get it. And the moment you have this, you have much, much better exploitation of water, of rainwater, because it can infiltrate and is protected from evaporation. You have the nutrients, and you get the perfect prairie condition to get high productivity. Now, if you have valleys, dry valleys, they're especially sensible to erosion by water, because sometimes we have rain, we have massive floods that carry away everything and leave just bare rocks. So this is a friend of the from the Abu Rabia family. They have a farm in the eastern desert with only about 150 millimeters of rain. They built beautiful stone terraces, planted olive trees inside this valley. It works wonderfully well. That's restoration, but classical restoration by agroforestry. They also get annual vegetation that can be eaten by the sheep. And it is a model example of how you can correct desertification. Then we had a research question, which was, I drove into a farm of a friend within the framework of another research project, and outside of his farm, the soil looked like this, like you see here. Inside the farm, the soil looked like this. So now it's a question, what are you doing? How did that happen? How does difference come along? So the simple answer was, first of all, he spread a little bit of manure, goat manure, and he never let the animals eat all of the vegetation. He always let some of the vegetation stand by the end of summer and took the herd in. And the difference is enormous. We analyze the difference in the soil between outside and inside, and they saw that the soil is simply much more fertile. And then we also noticed they planted some of those trees. It's called Acacia victoria. And it turned out that this is a miracle tree, because you see that underneath the tree, it increases the growth of grasses. Even this small one does the same thing. Turns out that the leaves, dry leaves that fall down, and the seeds that fall down from the tree create the litter layer that enriches the soil and fertility, and the shading by the tree probably also helps. We have under the tree higher soil moisture than outside, than here, which the guys in the university said, no, it cannot be under the tree, there must be less, because the tree drinks water. No, the tree does not drink water. The tree helps to safeguard water, because he makes litter and he makes shade, and therefore we get much more grass under the trees than outside. And if we put those Acacia victoria together into a more dense planting, we get an actual jungle at the same place with 220 millimeters of mean annual precipitation. Many, many years, it's much less than that. And we get 10 times higher services from this than we get here. We get about 10 tons of biological productivity per hectare and year. And of this, about 4 tons per hectare and year in CO2 sequestration in the soil, and another ton of wood production. This is just to demonstrate the soil moisture. In that highly productive woodland, we have high soil moisture during the winter. Outside, in the open land where we have no trees, we have only 40% of the soil moisture. The rest evaporates directly. It does not go through the plants. It simply evaporates directly by the sun rays that heat up the soil. Okay. Now then we got a very nice project with the help of the Sustainability Laboratory in New York. We got a piece of land to restore and to use. And the area we got was this heavily eroded desert land. You see here, I mean, it's completely smooth, the surface. There's no plant life there, and that's why the seeds don't capture by themselves. They can't regrow easily. Every time there is rain, every time there is wind, all the resources are blown away or washed away. So we stabilized those erosion gullies here and here by building dams across, over here as well. We planted here a plantation of olives. We planted inside those dams native and other trees and agroforestry trees. And the result looks like this. From this eroding wasteland that looks like this, we got, within 4 years, with minimal irrigation, a wonderful, productive, diverse agroforestry woodland. And grass started to grow as well for feeding the goats. This was transformed into this. And now we have a savanna, which is highly productive, very diverse in terms of biodiversity, produces a lot of fodder for the goats. And, well, if we had planted more Sisyphus here, for example, we would have gotten fruit from there as well. Okay? So if we look, we planted 34 tree species, of them 23 native, and about 18 of those survived. We planted 16 agroforestry species, most of them survived, and 8 nitrogen-fixing tree species. That's very important. They enrich the soil with nitrogen because nitrogen and all the nutrients are extremely limited in those soils at the beginning, and they come back with the activity of the trees, with nitrogen fixation, and with bringing nutrients from the deep soil. We are getting a much enriched topsoil layer, much more fertile. And we use the trees as windbreaks here. We use the trees for agroforestry, almond trees here, and obviously for erosion control and for biodiversity. That fox, she thought I don't see her because she's hidden behind the tree. Well, she was wrong, but anyway, I did not mean her any harm, so that was okay. So practical application of this, we have here the northern Negev. It's about 200,000 hectares, all of it heavily degraded like this, overgrazed lands of Bedouins and kibbutzim. We proposed them to make a serious restoration effort, like on 10,000 hectares or something like this. They did not agree, the government did not agree, and now with this, what is going right now, anyway, the chances are good for that. But it would have created a sink for about 1 million tons of CO2 emissions for Israel, which would be, well, it's not that much, but it is significant. Same could be done in Ethiopia, for example. That's written about 20 years ago. At that time, we could have sequestered sufficient CO2 to, at the price of $15 per ton, to cover about 30% of their gross national product. Today, they grow very fast, but that's why they are interested even less in that. And if we want to do something, we have to go through people that we know, that they work here, and people do excellent work in Ethiopia in spite of all the political problems we have there. And the results they get completely confirm of what we got here in the Negev. It's exactly the same. We control floods, we restore water cycles, we restore biodiversity, and we restore grazing lands. And many, many other countries we looked at as in a model, in a hypothetical form. In all of them, it could be the same. The problems to overcome are not science. The problems to overcome are not which trees to plant or how to plant them. The problems are not if it will work or not. We know that it will work. The problems are all social and political. Land ownership is very often not clear, so we cannot really work freely. Capital, where do we take the money from? Carbon trading is a nice thing, but nobody gives money ahead. time. If you work with drylands and dryland trees, you need the money ahead of time. Development of value chains, if you plant fruit trees, you should know to whom to sell them. You need expert project management to push that through, and that fails a lot. And then you need the rule of law. You need to be certain that when you start a project with forestry, you think ahead 20 years, 30 years. You should be sure that the project will stay standing for this period of time. And that's not certain in Africa, unfortunately. And corruption is a different story altogether. And now a short summary of the biodiversity, how biodiversity restores. It comes back. We got from 5 observable plant species in the degraded states to over 100 flowering plants, annual flowering plants, not trees. We planted 25 native tree species, tree and shrub species, which is 25 more than we had. Almost all the protected plant species returned. I will show you a few pictures now. Now, bird species. Birds go absolutely crazy by the fact that there are some trees there. All the Israel is a migration corridor for migrating birds from Europe to Africa and back. All the species that are migrating, all the small species, songbird species, came to rest on this piece of land. And they were extremely happy because there were a lot of seeds, there were a lot of insects as food, there were water puddles after rain, and it was really nice. They stayed there. Some of them even grew up some young in the spring and then moved ahead further north to do it once again. Now, mammals, we simply saw much more mammals. I don't really talk about species, but foxes and hares and mice, we simply see far more. Reptile numbers significantly are up. We saw snakes, we saw lizards, and even a tortoise. And insect, you know that there is an insect crisis in the world, and the reason is agriculture, modern agriculture, destroying soil, natural vegetation, and application of pesticides. Insects are disappearing. And I felt, after a few years of the project, I felt back into my childhood to see suddenly that huge number of butterflies and beetles and stuff. I show you some pictures. So what we often saw in the area is hares. These ones multiplied quite rapidly. Snakes, there are many snakes. Lizards, this is the lizard here, that guy, a beautiful one. A tortoise came back. It's endangered, also because of agriculture, solely because of agricultural activity. And then birds, this guy was very happy with the tree, that one as well, that one as well. So insects, butterflies, that's a beautiful one. We know it all. It is abundant from Israel through Europe to I don't know where. Where is the end of its distribution? I don't know. This one is a beautiful little one. Beetles, these are the ones that disappear. If you use herbicides and your pesticides and you don't let the native plants grow, you don't get any beetles like this. They are pollinators, they're alternative pollinators to bees. And we get all the protected plants, iconic plant species back into the land very rapidly. It means there are reserves of seeds and of bulbs in those degraded areas. You just have to give them the chance to recover and come back. Okay. Now, when we conclude, if we assume we could make a global dryland restoration project, we would address the United Nations Convention to combat desertification, of course. I mean, that's the purpose. We also addressed the United Nations Convention on Biological Diversity, which promotes protection of biodiversity, and the United Nations Framework Convention on Climate Change, because we have massive sequestration of carbon dioxide into restored soil and restored biomass. It would contribute to food and water security, socioeconomic development and economic growth, resilience and diversity. So it would address all sustainable development goals. And we get out of, if we talk about, let's say, we're 10 billion hectares of, 2 billion hectares of restored desert, we get back about 5 billion tons of food, feed, wood, fiber, above what we have currently, in a greenhouse gas negative and completely sustainable way, without intensive agriculture, without pesticide application, without tilling. So, I mean, these are goals that would be worthwhile to pursue if we want to reach a sustainable state of nature. And that's it for this part of the lecture. Thank you very much. Okay. Any questions?
Hello, I have a question.
Yes.
Thanks for your talk and for your time. That's worth a lot. So my question is, if we have an eroded landscape, like let's say in Morocco, if we go into the country from the sea, from the Mediterranean Sea or the Atlantic Sea, if we have this eroded landscape, should we start at the borders to the more fertile land in the peripheries to restore our ecosystems, or can we also just start wherever within the arid or semi-arid areas, because the technique is working well enough, so to say, that it doesn't really matter to do it like systematically from the more humid to the more arid areas? If that makes sense.
Well, of course it makes sense. In the more humid areas, it's much easier. Very often the first step that is very important to reduce the intensity of water runoff, both on the slopes and inside the gullies. If you can reduce the speed of water runoff, if you can stop the water with small dams, with check dams, if you can stop the runoff of water by applying a layer of mulch, plant litter, if available, anything like that, you get very rapidly improvement. What we did here in Wadi Atir, we started at the top. We stopped water runoff right from the top by making small check dams for every 1.5 meters of descent, so that the water can never achieve critical speed, destructive speed. And then the water stays there, and you automatically already get a higher level of vegetation. And that is was extremely instructive, the way that was working. And the planting of trees or perennial plants is very important, especially in those gullies and along those check dams, to stabilize the soil. Otherwise, it may be washed out anyway. And it really depends where the land is the most suitable. It could be in a drier area that you have a more suitable topography to work with, a better soil properties, less slope, less rocks, more soil. could even work better in a drier area than in a more moist area where you have only washed out soils, washed out rocks, because that can happen. Because the rains in drylands can be very intensive sometimes, and if you have a rocky landscape, all the soil can be washed out, and then it is very difficult to restore that soil. You can do it by doing a check dam, but then you have to wait until some soil has accumulated back before you can start planting.
Okay. Thank you.
You're welcome.
Okay, then we got another question from the chat. What was the cost for reforestating projects, experiments that you did? Can you make an estimate of how much money you would need per hectare?
Yeah. I mean, in the project Variatir, one major cost is, first of all, is making a fence, okay, around the area that you want to restore. Because there were still a lot of wandering herds around, you have to keep them out. You have to control your grazing, and if you have a well-functioning community that controls their herds well, you don't need a fence. If you need a fence, it's about, let's say, $4,000 per hectare, something like this. Okay, that's one cost. Seedlings of plants are not expensive. Actually, we bought commercially in a commercial seed producing nursery. Hundreds, actually. She made so many. She had such good germination of those acacia that we gave to her, that she made us hundreds of seedlings and did not even charge the money anymore. She just charged for the process a very small number. And then the planting, if you have to pay for planting, that's according to the hourly salary. You can easily plant 100 plants per hour, something like this, if the soil is reasonably good, and we have small plants. And then if you have to do landscaping, that can become expensive. If you have huge gullies that you want to fill in, it can become, and then you have to calculate how many tractor hours you would need to do that. But on a flat area that you simply want to fence and to plant a few hundred trees per hectare, I would say it's not more than $5,000, $6,000 per hectare. With fencing, and without fencing, it is $1,000, $2,000 per hectare.
Okay, that's for the questions for now. If you're ready, you can continue with your presentation, and then we would do another 10-minute sessions of questions at the end.
Okay, so that's the last, and now that's the culmination. That's an extremely ambitious piece of fantasy from my side. And it's basically something like starting a huge reverse pyramid scheme to try to really achieve something at a global scale. Because if we look at this, where is the full screen here? The question is really, how can we achieve that in a large scale? I showed you before, even when we tried to move from 10 hectares to 1,000 hectares or 10,000 hectares in Israel, we failed. We did not get the land, even though the how do you say, the proof physically was there that it works. It's easy to be done. It failed because there were no land rights, and there's actually disputed land rights, which is the worst of all. And we are trying actually with a couple of colleagues to get access to 10,000, 100,000 hectare projects. Can we do that? How can we do that? How can we get there? And it is very difficult. You need funding first. Some could be done, but you need agreement of the landowners, of the countries involved, of the local residents, local inhabitants, and everything. It's a big trouble. So, scientifically speaking, we have shown that natural carbon removal is technically easy, cheap, immediately effective, and scalable at will. Well, the scalable at will would be if you would get access to land, to the land. And if we don't have that, we are already stuck. Now, I have also showed the other greenhouse gas mitigation measures, like renewable energies and the more advanced technologies, are successful, very successful, but they're slow and very expensive. So it will take a long time until they have the necessary effect. Now, if we want to achieve any mitigation soon, the only rapid measures are the nature-based. And that is a complete reversal of all IPCC priorities, unfortunately, because if you read the reports of IPCC, they recommend everything else first before nature-based solutions. And just to go again. Hello? Okay. You hear me? Okay. What we have to be aware first, those things that are always and generally being recommended, and in some cases gather hundreds of millions or billions of investments early on, they are far too slow, far too expensive, very often serve only the rich, and therefore have zero social impact. I mean, nobody earns something from building a huge photovoltaic plant except the ones that sell the stuff. And nobody earns from electric cars except the one that sells the electric cars. And that's a pity. So if we look at what will not work, what is often recommended as a last resort, like nuclear power. We know that in Germany and in Switzerland, for example, it has been decided to turn them off. Now people from the right-wing spectrum of the government want to bring them back. First of all, it has to pass the whole democratic process. In Switzerland, that by himself can take 10 years or 20 years. Then planning a new plant, building it and installing it. So until we would get any electricity from a new power plant would in Switzerland probably be at least 30 years. With a very significant investment of energy to do that and resources, there is always a chance for an accident during the lifetime. It's a 1% chance for a serious accident based on today's statistics. And it will remove only 80 to 90% of CO2 emissions, because building and running a nuclear power plant also needs energy that has to come somewhere. The alternatives are already renewable energies. Now, electric cars, situation is even worse. First of all, based on today's kinetics, it would take 20 to 40 years until they are effective in high numbers. They save only about 50% of energy fuel use. Once the whole economy is based on renewable electricity, we would have about 75% saving. The proper alternative is obviously is public transportation, transported by electricity. Now, a very adventurous thing, because I work with algae, I know a little, I understand about that, is sinking algae in the sea. And those guys have gathered hundreds of millions of investments from Bill Gates, not that the least. The chances of it to work are zero. Okay, I tell you that as algae expert. If Gates would have asked me, he could have saved his money. The risks are extremely high. The risk is very high that we cause massive eutrophication in the ocean, which will release methane gas, will kill all the fish and creatures below the ocean. And if you want to do something with algae, there are millions of tons of sargassum grass floating every year in the Sargasso Sea. That can be, and its amounts are growing. And it can be harvested, it can be transformed into biofuels, into fertilizers and bioproducts. No problem with that. That is perfect. But the sinking of algae in the ocean is absolute nonsense. Next, high-speed rail is not efficient. Medium-speed rail with night trains is far better for distances up to 1,500 kilometers. And then you can make renewable jet fuels for longer distances. Direct air capture, I have a slide for that, does not work. A forest is 1,000 times better than any kind of direct CO2 capture. Much faster installed, much cheaper to install, gives much more side benefits, as we have heard in the last two lectures. And it's complete nonsense. But companies have been earning hundreds of millions on that already. And then hydrogen is even worse. Unless recent rumors are true that there are large reserves of fossil hydrogen underground that could be harvested. That's a possibility. And that's a gamble. What I wanted to say, one giant oil company, they promised to develop this carbon dioxide capture from the atmosphere and therefore reduce the footprint of their oil operations to zero. It failed and they stopped it. Nobody hears about that. When they start the thing, everybody makes big noise. When they stop it because it failed, nobody hears about it, but it failed. And that's what will happen to this carbon capture project. Now, whom should we address to fix the problems of global warming? There are rumors that, the poor countries should not have to pay. We should pay the poor countries, which is okay, which is certain. But now, which of the rich countries should pay most? These are the carbon dioxide emissions of the G20 countries. And you see there are few are sticking out. I mean, it's unbelievable. Australia, Saudi Arabia, United States, and Canada. What are they doing? I have no idea what they do to emit so much CO2. But in the United States, I know. I've been there, I've seen. They don't know to build. Their cars simply send out CO2 in tons. And in other countries, Canada, Australia, I don't really understand. But the European countries still emit far too much. I guess per person we should not emit more than 1 ton to reach some kind of equilibrium in one time. And so there's no space for mutual blame games anymore. The third world emits as much as the first world, in some cases even more, and everybody has to contribute, and the best is to contribute according to what you can do. If you have large areas of sun-rich country like Saudi Arabia, you could do all the electricity for the world. If you have large areas of forest, you could make renewable electricity from wood harvested in those forests. If you have large areas of degraded forests, you can contribute by planting those areas back, and so on. And all of this can be done. It just needs to be decided and done by the countries themselves. They are rich enough. They can do it, start it tomorrow. And I showed you this graph already. We should be down here right now, but we are up here, and nothing is moving. And if anybody thinks that the conference that will be down there in the Emirates will achieve something, then, well, I think you are a little bit naive. Nothing will be achieved there because nobody actually wants. And what we need to achieve, we are here, we need to induce carbon removal of at least 20 gigatons of CO2 right now. Not in 30 years, not in 50 years, not by 2050, and not by 2100. It needs to be done now. The only way to do that is really biological CO2 removal. And I told you already some things. The best is to put it into degraded soils or degraded farmlands. That is easy. You can simply make a law that tilling is no longer allowed. You make no-till agriculture as of now. You make you cut your wheat 30 centimeters above the ground as recommended about 30 years ago by some USDA scientist, because then you maintain the carbon stocks in the soil. Or you take degraded forests and restore them. Or you stop deforestation, the easiest thing in the world. That's 7 gigatons or 8 gigatons of CO2 per year. It can be done just by law. Send your army, protect the forests, and that's it. No more deforestation. So what I put together now is 42 gigatons of low-hanging fruit. I mean, it simply can be done just by decree. You don't even have to plant. You don't have to restore deserts. You have an immediately available potential with very high impact. Okay. This has, by the way, been recognized by IPCC a long time ago, that the biological CO2 removal can play an immediate role and can also significantly contribute to achieving several other sustainable development goals. So if you have this written, and what you are in IPCC, what are you doing there? Why aren't you doing anything? Now, we can actually separate and classify the possible means by impact and speed. Then you get a very clear classification of what to do first. Do first is stopping deforestation, highest impact, lowest cost, and stops 7 to 8 gigatons per year. Now, sustainable forestry, that's what we do in Switzerland. If you cut down trees, you harvest trees, you come back the next spring with seedlings and plant the empty spaces back. Clear cutting is not allowed. It's not sustainable. You cannot do clear cutting. I showed you before the impact of the mutual impact of trees on each other, on the microclimate. If you clear cut to destroy the microclimate, and it takes very long until that forest comes back. Replanting right away. Reversing biosphere and soil degradation, I have shown you how to do it. It's pretty easy to do. That applies to rangelands, that applies to farmlands, that applies to ecosystem restoration, that applies to rewilding and conservancy approaches. Many gigatons per year possible to gain. 10. And forest fires, that's a new threat. That's a feedback from the global warming. Almost every piece of forest in the world now is threatened by forest fires. So we have to be ready for that. There are super tankers that can drop down 150 tons of water on a forest fire the moment it's detected. You can detect forest fires by satellite, send a WhatsApp to a super tanker standing somewhere around. He can go 5,000 kilometers if he wants with 100 tons of water, extinguish that fire before it gets even bigger than a hectare. Because all those sensors are up there. They're just up there for the military, but to detect infrared. But they're up there. You can detect the forest fire the moment it reaches 10 or 20 square meters. And then other forest-based mitigation, taking out the wood to make energy, taking out wood, and if you have too much old wood, you have to leave old wood. We know that. But if you have too much, it becomes a fire danger. You can take out the old wood and carbonize it, turn it into carbon, put it in the soil, make biochar, and so on. So then we have immediate solutions in the food sector, promote vegan nutrition, and this encourage eating of meat and even milk products. Take all food waste. I first avoid it, and second, convert it into energy and fertilizer. That's the thing. That's my profession. That works wonderfully well. Then a very attractive subject is planting mangroves. Almost all mangroves around the world have been removed. Replant them. Then methane is another thing. Half of the methane emissions come from a leaking seal. Okay, and it can be detected from space by now. So fix those seals and you cut methane emissions by 50%. That's corresponding to 5 to 15 gigatons of CO2 emissions. Okay, and then the only thing that is really important now, we want to develop, to help people develop also in Africa, also in remote areas, marginalized areas, rural microgrids based on photovoltaics and electricity storage, based by some electric vehicles. That's a wonderful idea, easy to be done, and immediate. So that's also a saving potential of 5 gigatons. So yeah, supporting sources are from the United Nations Environment Program, for example. They have a nice publication on that. And my old publication. Then there is a paper from Oxford, State of Carbon Dioxide Removal. They concur more or less with the numbers I put in here. Those guys up here as well. And then, does it work? It has been done top down in Switzerland 170 or 180 years ago, simply by decreeing a law. The federal government is now responsible for all watersheds, slopes that have to be protected, and every piece of forest is under protection, and it requires a permit to cut down. And if you cut down forest, you have to replant the same area somewhere else. Okay, very simple law. Okay. Apply that to the world, and we are saved. In Israel, we planted about 150,000 hectares in the last 100 years. And it also reversed the advance of the desert. stopped erosion and flooding and restored hydrological cycles. We have some springs restored and so on. And we have recovering biodiversity. It works. It does work. Top-down approach works. If a government decides, gives the laws and the support to do it, it is being done. Okay. In the USA, for example, the most impactful thing would be to restore the prairies, to turn the prairies back into carbon-fixing grasslands instead of carbon-releasing grasslands. And it's easily done just by law. No-till agriculture from that moment on, and also stop feedlot cattle, to stop the cultivation of maize for those animals. They can live from grass. You don't need to plant for them the maize. And the potentials are unlimited, just needs to be done. Does not need the permit of anybody. Every government can do that by themselves. Bison turns out to be the new star in land restoration. You release them in some desertified pieces of prairies, and they start munching around, they start trampling around and improving the soil, not destroying the soil, improving the vegetation, everything. So that's wonderful. Now, a global desertification program led by the EU, oil and Mediterranean states, so states that have a lot of money. All that black stuff has been desertified 2,000 to 5,000 years ago. This gray stuff has been desertified more recently. So we need to restore vegetation. The first thing, we have the green wall along the South Sahara. It's only about 10 or 15% implemented. It starts to work. People have understood how to do it. Then we have a green wall in southern Arabia, can be done. We have a green wall across North Africa, reaching Ethiopia. We have a green wall through southern Europe into Turkey and Central Asia. All of it the same climate, Mediterranean type climate, desertified, degraded soils, all applicable with the things we showed in Israel, in Wadi Atir. Fits exactly like this. And that gives at least 2 gigatons per year of sequestration with the ecological and agricultural profit. And the problem is political and security obstacles. I know many people that have been working in Niger and in Mali, for example. And those are simply not places where you can go and work these days. And it is a pity. And these are huge areas that are out of control now. Now, Australia, I mean, they can just do it. I mean, you make a belt of Acacia victoria surrounding the arid center, and and you can export renewable energies from Australia into Asia. You ditch your coal as a trivial program to do for a new government. And you remember that picture? This is an Australian species that we checked in Israel. It will do the same thing in Australia. They can raise as many cattle and as many sheep as they want on that grass that could be produced there. Brazil, the same thing. These huge areas, they mostly have been abandoned because those lands have actually functionally turned from rainforest into functional desert. Now it has to be restored. And how can it be restored? Some rich people could actually simply buy those degraded lands, and we could start to recover it. I can give you the program for that any time if anybody has 100 billion. There are people that have 100 billion, so it could be done easily. And you can create products from those areas, and you can create carbon sequestration, and you can restore the water cycle, and everything would be just nice. So Africa is the last rapidly growing continent, ideal for this rural microgrid idea. They have the sun, they have wind, and it is also ideal to establish conservancies, because ecotourism is extremely popular. And I have been working on a couple of studies, but so far we didn't yet get to realize anything. This is a conservancy in Kenya. It's semi-arid, doesn't look like this. It's just after the start of the rainy season. In the dry season, that river was completely empty and there was not any green plant here. Now the hippos are happy and the elephants as well, extremely happy. But these are conservancies, and this area of Kenya has now the highest density of elephants and lions in the whole country, even though none of it is a national park. Those areas are actually ecologically better than national parks, even though there are farmers there, there are cattle herds there, together with ecotourism, and they protect now the land. You don't have to be afraid of poachers. They do it. They stop the poachers. They control the land, and it's a perfect approach for Africa and for other parts of the world. Now, another thing is a voluntary project done by a few colleagues that I met with the help of Emil Underberg. I, by the way, have to thank Emil Underberg. He has introduced me to this whole community, and to Marius, who has invited me to give the lecture. And one of his friends, called Paul, is working in Uganda on a restoration plant and on a reforestation project. And it works fantastically well. The community there plants hundreds of thousands of trees on degraded slopes, and that's the way it looks before and after planting. If you look on this by satellite, you see before and after the replanted forests. And if you're interested, you have the contacts here. And so, yeah, I still have half a minute or a minute. So it's actually supported by a foundation called Urban Street Forests, a guy called Raymond Brouwers and Paul Bauer. Now, bottom-up approach is more promising maybe in Europe, where there are lots of private lands. You have a high legal security. I have to go through that because I just started a farm in Spain. There are huge land areas in Spain. Spain is threatened by desertification, requires land improvement. But there is, in my mind, quite a lot of precipitation. Technically, it's not difficult to restore that land to full functionality. I will show you just now. You just have to stop this. Prohibit tilling. Tilling in Spain is the single one disaster. Make no-till agriculture, make no-till growth of trees, and it's the simplest thing in the world, and you start getting carbon sequestration. All the bright places here are over-tilled. They can't be restored. We have 3 teams working in 3 different places around space with different climates. 1 is the toughest, 2 is the easiest in terms of precipitation. This is the farm I just acquired. And you see here how carbon is being sequestration into the soil when you let it rest. That's the last time the farm was tilled, 2015. Today it looks like this. It's all dark. The dark stuff is annual vegetation between the trees. And this means soil carbon sequestration. And I have plans for this place, of course, planting the trees much denser. They work there with 10-meter spacing of trees, which is crazy. You can have them in 4-meter spacing, it's good enough. So you could have 2.5, you can have 4 times, 5 times more trees in the same area to get more fruit and to get more sequestration. And the major idea I have here about the pyramid scheme is really, if we can double the number of participating entities per year, double the number of associated landowners that do the same thing, double the amounts of land acquired per year, then we get the multiplication factor of 8, which is very huge, of course. If we make exponential calculation, we would get out of existing 100 hectares, we would get 10 billion hectares in 10 years, which is obviously fantasy, but still, if we can exponentially grow the number of participating people, we get an exponential function to rapidly gain massive amounts of land under restoration. Private lands, that's the important thing, private lands. And that's the end of my talk. This is an idea I just throw out into the space. I have already thrown it into the team that we have put together. And stop that lecture here. Thank to Dr. Carmen Sella, who is my wife, for many fruitful discussions. Dr. Amir Museri, who did much of the soil and scientific fieldwork during making his PhD thesis. Emil Anderberg, he started introducing me into the whole team and into the whole Spain idea. And Marius and Francisca, thanks for the invitation to the lecture. And here's my contacts. You can write me, you can send me a WhatsApp anytime. Sometimes I answer immediately, sometimes a little bit less immediately, but I will answer. Thank you very much. Okay. And that's it. And here we are.
Thank you very much. I just want to underline that there are several different associations what are in the way or in the direction to regenerate the earth. So there are, yeah, I think this is possible, and we just need the hope and yeah, the power of the people, and we can do it. So we have some more questions in the chat, and I could start with them, and also we have like 2 minutes left, so we are a little bit short of time. But I don't know, Stefan, how long do you have time?
Well, I have time right now. I don't have to run anywhere.
Okay.
So if there are questions, I'm happy to answer. Also, as I said, I'm very happy to answer to any questions by mail or by WhatsApp. And any questions, suggestions, criticism, I will be very happy to get the criticism, constructive criticism, I mean, and to answer any questions. Okay.
Okay, so we continue now. And yeah, thank you for all the questions in the chat, and thank you to you, Stefan, as well again. So we have a question from Svenja. This was at 19 o'clock around. In Mediterranean areas, can forests sustain themselves after they have been reforested?
If the forest can self-sustain, yes, of course.
Okay.
Of course, I mean, we have here some actually recovered in areas that are in the more moist, semi-arid, and you will also see those forests in Spain and in Israel. You get wonderful ecosystems restored that are woodlands. In some areas in Spain, it's called maqui. In Israel, it's called choresh. It's all of native trees, pistacia, oak. They survive without any problem from 250 millimeters of precipitation upwards. Absolutely no problem. And I believe they could survive even at lower amounts of precipitation.
Okay. Then we have a question from Carsten Rech. Trees lead to formation of clouds, but if the clouds are moved by wind, it rains elsewhere, but not at the area where the transpiration happened. Or does the planting trees lead to rain at the specific area? What are usual distances between the locations of transpiration and rainfall? For example, in Middle Europe.
A very normal phenomenon is that it will rain in the mountains. Okay, if the forests are downhill, and there is a very nice paper that brought this subject up about 30 years ago from Central America. You have down lowland forest, which evaporates, and the clouds are created when the wind moves that moist air into the mountains, into the hills. And it starts climbing up, and you get most of the rain there. And it's a normal phenomenon that you get most of the rain always along the mountain slopes. And but for example, I have been in Spain this summer, and behind a forest, a very nice piece of forest, an enormous thunderstorm unloaded on top of me in the flatland without mountains there. So it happens as well. It's very hard to say how far that moisture is transported before it rains.
Okay. Carsten, is your answer clear so far? If not, then just type in another question. Then there's a question from Felix Kamalha. I hope I pronounce it right. Can there be a chance of nature restoration itself if human activity is completely stopped over a considerably large plot of land?
Yes, there is. Of course, there is. What we see, I mean, we have very good data now from Israel, because until about 10 years ago, a free open range grazing was allowed by sheep, okay, by sheep and goats. And they used to remove every single piece of vegetation. And that was stopped actually by tax laws. And it isn't done anymore. It's not worthwhile anymore. And the annual vegetation starts recovering. When we now travel through southern Israel, we see dried vegetation standing on the plains. And trees, that's a different story. The dynamics of trees in drylands is very, very slow. Now, let's say acacia produce maybe 2 or 3 offsprings during their life. Which means even if I have a few dozen acacia per square kilometer now, until I get a nice acacia savanna, it will take eternally to get them back, to get that population back. Another tree that's Sisyphus likes to grow along erosion gullies, and it distributes much faster. If you have one uphill, you will start seeing trees coming up, a young one, every 50 meters, pretty rapidly. Within years, you start to see them multiplying. So it's for each species is different. And because nobody actually know how the nature looked there 5,000 years ago, so we don't really know to which state can we finally get in those dry areas, because we don't know how it was looking then.
Now we have a question from somebody here who is here.
Yes, 2 questions actually. First of all, thank you for the lecture. my first question is more of a remark, really. Do you know the Copernicus program run by the European Space Agency? It's basically what you proposed about using satellite systems to spot forest fires. Copernicus is a program that uses a range of different satellites to do quite a few things regarding Earth monitoring. And among those things is also infrared imaging, and the data that is being gathered there is currently developed to be used in forest fire detection. And
okay, good.
Yeah.
I was rather thinking of military satellites that are actually built for that, to detect a small hot area somewhere across enemy territory. But if Copernicus is doing that, that's perfect. I know them, of course. Many of the weather graphs and data that I showed are coming from there.
Yeah. And my second question goes back to the second part of your presentation about those carbon sequestration rates. I'd be interested to know if these rates that you posted, if they are stable over time, or if they drop once the plantation gets older, the trees get taller, they are slowing down their growth, and the soil becomes more saturated with carbon.
What I know, there are data from Yatir Forest that's about 60 years old now, over 60 years old now, and carbon sequestration rates are more or less remaining stable because the trees are still very thin. A pine tree can reach a diameter of 1 meter in the end. Right now, they are anywhere between 30 and 60 centimeters thick. And much of the sequestration happens in the soil by rebuilding soil. And there, nobody actually has started to check how deep down that carbon is being sequestered. In the papers I have been reviewing for my last publication, a Chinese group monitored increase of soil carbon until 3 meters deep. And they got sequestration down there as well, which means our measurements for soil carbon sequestration is only for the top 20 centimeters. If these rates continue down to 3 meters, the potential is far higher than we thought, and it will last much longer.
I've got a question. Do you hear me?
Yes.
Okay. I would like to know, because you were talking about different issues. On the one hand, you were talking in Spain about using also acacia species and other fast-growing nitrogen fixing. No.
No, in Spain, no. I would not bring in foreign species into Spain. Well, I was thinking about planting pecan trees, but that's for the agroforestry part. They make nuts, valuable nuts to be eaten, of course, but no acacia for Spain.
And why do you think so? Because acacias or other fast-growing species could regenerate really fast landscape in combination also with other trees, which could be nuts and fruits and things like that. This is one of the things or thoughts I have, and the other is take care of the social process in the habitats where you are doing your intervention. And I mean social process because there are people living there, and the SDGs, what you're talking about, they should be applied so that consciousness could come in.
Yeah, I mean that's the heart of the matter. I mean, if like as we say here, if we that's why one point is we work on private lands. Okay, we are integrated into the local community. We don't take anything from anybody. In the contrary, we want to involve the neighbors to apply the same things. I think in places like Spain, that would be perfectly acceptable and they would not create any problems. For Africa, what I said, like the conservancy approach in Africa, it's almost always it's centered around tribal lands. And those tribes are the ones that initiate and participate in the project. They are doing it. It's not any kind of foreign guy that comes and buys the land and says, okay, we are taking this and doing it. That's not the way it can work. It has been done 30 years ago that carbon sequestration companies went to Ethiopia and the corrupt officials gave them land to occupy and to replant without asking the tribes. And then they got into trouble, of course. That's not the way it can work. It can only work if the question of land ownership, the question of participation are absolutely clear. Okay.
Stefan, can you see this chat?
Where is the chat?
Because there's a question of RCC at 1945.
I can also save myself.
Yeah.
If
you
you
could
want to
ask also,
yeah, because it's the Hebrew word. Yeah, it's not directly to your lecture, but I've wondered about something, and I always needed somebody who knows both Hebrew and agroforestry systems, because I wonder, when you've got an agroforest system, would you say that the community of trees standing on it can be referred to as Ya'ar?
Well, we have two expressions. Yeah, if in Israel, the things that have been planted artificially, like pine or eucalyptus, we call them Yar. Okay? If it's a native mixture of recovering Mediterranean maki, we call it choresh. Choresh is much more species diverse. It does not have a lot of high trees, but it has a huge number of different perennial trees there with the native oaks, the pistacia, and many others. And this one we call choresh. Okay.
So if I've got a whole series of apple and some other fruit trees on some green land, would that be Ya'ar? Because it's one sort of trees?
With apple trees?
Yeah.
No, that would be a mata.
Okay.
It's like an orchard. I mean, there's a name for orchard, and that's a mata.
Perhaps I'll ask you again via WhatsApp, because if I need the words. But thank you very much.
You're welcome.
Here's one more question. Where all questions have started and are necessary to do is very interesting, maybe for school classes to help or volunteers. So do you have like a map somewhere, or where people can maybe join in action?
Not at the moment, not yet. We had a project where we involved a lot of pupils and students and visitors from abroad. That was the project Vadiatir. Right now, it's not working that way at the moment. And I would like in Spain to establish a location where people could come, could assist, could even learn and study. and assist in expanding the idea, assist in enriching the farm as it is. But that is in the future. That's not right now.
Yeah, thank you very much. So here are just 2 people left in the room, and 24 people in the chat. And yeah, thank you again for your time and your preparing and doing the 3 hours in the midday with me. And yeah, for you it's really long day now, and I think we can yeah, close here. And yeah, if some people would like to help in Spain in the future, just yeah, give me a call maybe, or write me in text, and then I will see if we can arrange something with Stefan. So I would say the last words are up to you. And yeah, thank you from my side and the audience.
Okay. Thank you very much. So, as I said, if somebody felt challenged by the things I suggested, like trying to create an avalanche of land restoration activities, first locally, then globally, and so on, I mean, that's the thing to do. Private initiative cannot be beaten by any public activities. Joining private initiatives together and enlarging the whole thing, that could work. And much faster than going through governments, through grants, going through any kind of public funding. That will be very slow and probably too slow. So I don't know, you have my contacts written up there, and as I said, I'll be happy to answer and discuss any suggestions. And thank you for your attention.
Thank you very much. So
you're welcome.
Close here, and then yeah, see that we get out of the university. And yeah, thank you again, and
thanks a lot. Okay.
See you. Bye.
Bye. Thank you very much.